Hello everyone, in this video I'm going to be writing this logarithmic expression and it's in expanded form. So let's just go ahead and jump right into it. So the first thing I see is this cube root symbol, this radical symbol. So that can be written as a power. So it's all to the 1/3 power. It's a 1/3 written as an exponent. And we know that exponents can be written as numbers in front of a log. So it's the product of what was the power times the logarithm. So then we have this right here, 1/3 times log base 5 of 25 over a squared plus b all squared. And of course, we're taking 1/3 and we're multiplying it to all of this. And so then we have 1/3 times, we're taking the log base 5 of a quotient. So log base 5 of 25 minus log base 5 of a squared plus b all squared, because since we have the log of a quotient, we can use the quotient property. So 2, where you subtract the log of the numerator and the log of the denominator. Okay, and then what I see here is log base 5 of 25, and I know that's a 2. And this, again, this power, we can use a power property of logarithms that can be written as number up front times the log, so a squared plus b. So we have what we have right here. We brought down the exponent in front, so we have 2 log base 5 times a squared plus b. And then last, I can distribute the 1/3 throughout everything in the parentheses. So 1/3 times 2 is 2/3. And then 1/3 times minus 2 log base 5 of a squared plus b is minus 2/3 log base 5 of a squared plus b. And that's it. That's how you write that logarithmic expression in its expanded form. And then we can do one where we write it in condensed form, where we go the other way. So here I see that I have this number right in front of the log. So that can be written as a power. And so can this 3, right, using the power property of logs. And I see here, what I notice here is I have a sum of 2 logs. So that's the same thing as the log of one of the arguments times the other argument, right? So we have all that. And then what I see is I have log base 2 to the second power, so that's log 4. And I have plus log x cubed. And this 1/2 is, again, a number written in front of a log. So we have the product of this number and this log. So that can be written as a power. So it's log of x plus 3 times x minus 2 all to the 1/2 power. And so what I then notice, I have a sum of 2 logs, and I can use the product property of logarithms. So that states when you have a sum of 2 logs, then you multiply one argument times the other. And I'm subtracting the log. I'm going to write this 1/2 power, that is the same thing as a square root. And I can multiply this out as well. So it's x squared. So it's first outside is negative 2x and inside is positive 3x minus 6. And of course, this will become the log of the square root of x squared plus x minus 6, right? We combine like terms, equals. And then I am subtracting two logs. So the quotient property of log states when you subtract two logs with the same base, then that's equal to the log of one argument divided by the other argument. And that is it. That is how we write this sum and difference of logarithmic expressions into a condensed form. So again, the first thing that what you usually do is use the power property of logarithms if it's the easiest. And here for this expression and this one it was, so I brought the 2 on top and this 3 on top. As far as this is concerned, the sum of these two logs is what I wanted to get condensed first. So I use the product property of logs. So that just says I take the log of one argument times the log of the other times the other argument. And then next step, I simplified 2 squared, which is 4. And on that same step, I noticed, okay, I'll go ahead and use the power property of logs here. So I went ahead and brought that coefficient, that number from the log, up to the top as an exponent. And then here I had a sum of two logs, so that means I can use a product property of logs, means I can take the log of the product of the factors, so 4 times x cubed. And I had minus the log of, I changed this 1/2 exponent. We know that's the same thing as a square root, and I multiplied these two binomials. And on the next step, I simplified that. And then last, I had the difference of two logs. So that will lead me to use a quotient property of logarithms, where I took the log of the numerator, the log of one of the arguments, which is now the numerator, and I divided by the argument of the other log, and that, of course, that becomes the denominator. And that's it. In our previous problem, we went from condensed to expanded, right? So we had the log of we just had one log, and then we expanded it. So again, a cube root can be written as, so a root can be written as a power, and cube root is a 1/3 power, and we use the power property of log, so we brought the 1/3 to the front times the log base 5 of a quotient. So that's the log base 5 of the numerator minus the log base 5 of the denominator. And the next step, we use the power property of log, so we brought the power to the front. So it's the power times, what was the power times the log of the argument, and log base 5 of 25 is 2. And then last, I distributed 1/3, right? 1/3 times all of this. So I distributed 1/3 to everything within the parentheses. So we multiplied and we got this. All right, that is all I have for now, guys. Feel free to check out my other videos. I have tons of videos on other topics. I really hoped all of this helped. And yeah, check out my other videos, and I'll see you on the next video. Thanks, guys. Bye.